I'm Luke Marsden from MLOps Consulting. I've been working on making some new AI models work really well on Dagger. So I'm going to take you through some of that. The context here is that open source AI is accelerating really rapidly. So I gave a talk at the community meeting 4 months ago, and I demoed fine-tuning the original Stable Diffusion 1.5 to allow you to, for example, generate brand assets from a set of images that you have, and then get the AI to make things that look like that. And it was kind of promising, but the results were not very good, to be honest. And since then, we've seen SDXL come out, and we've also seen the emergence of some very new and interesting language models that are small open source language models that are very good, and that's what Mistral-7B is. So I'm going to show you some of these things. But first, I want to take you through. I'm going to kick off a demo because it'll take a few minutes to run, and then we can come back to slides while we wait for it. So the first demo I want to show you is so I was working on a business use case for a real estate company, and the idea for this real estate company, this real estate agent here in the UK, we call them estate agents, was to be able to take photos of houses and the kind of for sale sign or the sold sign that they have, and feed those into a model and fine-tune a model that that knows what the brand looks like and also knows what the houses look like in the area where they operate, which is here in Bristol, and generate similar looking images. And so here we can see this was the input. This is a real photograph, and this was the output. This is AI generated. And so if you compare this is with SDXL 1.0 with fine tuning. And if you compare the quality of this to what we saw 4 months ago with the original Stable Diffusion 1.5, it's really significantly better. So I generated this image with Dagger. I'll show you how I did that quickly, and then we can kick off another run. Yeah, hopefully you can all see VS Code here. What I have here is a config file that drives this Dagger pipeline in this SDXL LoRa file here. I won't go through all the code right now because we're a bit short on time, but what you can see here is that given an input, which is this, for example, this image along with the label or the caption CJ Hole sold sign outside a posh house, and then another one which is a CJ Hole for sale sign outside a council house, and then another one which is a picture of a street. You just teach the model what's in the picture, and it's clever enough to pull out and to be able to distinguish between for sale signs and sold signs, for example. So that's pretty nice. You can, there are another few examples here. This was another one. It's pretty accurate at getting the branding right based on the logo, which it's probably never seen before it was fine-tuned. And I quite like this one. This was the prompt where we said a posh house with a Tesla in winter with snow. And like, it's pretty good. I mean, you could imagine using that in a marketing campaign for this real estate company. So I wanted to invite a little bit of audience participation. Let's add a new prompt and then rerun Dagger. And yeah, so anyone want to suggest? What I found was it works quite well when you choose different types of cars. So does anyone want to shout out or put in the chat a make of car that they would like to put in this picture? And I will come and look at the Q&A.
Any suggestions in the chat, everyone?
A Jeep, a Porsche 911. Ah, cool. Okay, excellent. I'm going to go Porsche 911. Right, let's do that. And I need to give it a unique key here. And then what I'm going to do is I'm going to run the, I've got, this is all open source. You can go look at this repo yourself if you're interested, yourselves if you're interested. So I'm going to hit Python SDXL LoRa. Now it takes about 8 minutes to fine tune the model based on the input data. The thing that's really nice about Dagger is that this uses the Dagger cache. So Dagger knows that it's already done the expensive, slow fine-tuning thing. And it also knows that it's already done all of the other inference jobs for those images. And you can hear the GPU behind me spinning up. So I'm pretty sure it's running. That'll take 10 to 15 seconds. And then we should get a new image show up in this interface here. Probably that one. Yeah, the one from 4 seconds ago. Let's see if it got a Porsche 911. Not bad. I'm not an expert on cars, but that does look a bit like a Porsche. So that's pretty cool. Okay. So I wanted to spend a bit of time talking about the kind of state of the world in terms of AI models, because it feels like it's accelerating, and things are happening quite quickly now, which is quite interesting. So one big change recently is that we are starting to see the emergence of these smaller open source models that are good enough that they are beating larger models in some pretty interesting benchmarks. So one that came out just a month ago or so was called is called Mistral-7B. 7B means 7 billion, so 7 billion parameters. Now, models are measured in terms of how many parameters they are. It's basically how big they are. So Mistral-7B, for example, is only 7 billion parameters, whereas a larger model would be 70 billion. Can everyone hear me okay, by the way? I noticed my video is a bit jumpy.
Sounds good. For me.
Yeah, okay, fine, great. The interesting thing about these models is also that people are now fine-tuning the models on their own data sets. So when it comes to language models here, for example, you can see that Mistral-7B came out, and then the community of open source people on the internet started playing with it and put out new models that kind of built on top of it. So there's this guy, Technium, who is putting out models on X and beating lots of benchmarks. And then other people saying like, well, 10 to 15 billion parameter models are going to be outperforming all the state of the art soon. And I think there's some interesting implications to open source models being runnable locally on your own private data set versus sending all your data to a company like OpenAI. So the other big thing that happened was that Stable Diffusion XL came out, and it's much better. So if you've probably seen some of these kinds of images, but they look a lot more photorealistic, and we're kind of rapidly moving towards a place where these images are not just toys anymore, but they're actually like really usable. And then the other interesting thing that's happening is that the open source community is squeezing models onto smaller and smaller hardware. So here's a pull request I opened, for example, just getting the Mistral fine-tuning working on a single 4090, which is a consumer-grade GPU with just 24 gigs of RAM. And a few weeks ago, it was unthinkable to fine-tune a language model on a single consumer GPU, and now you can do it. So it's quite interesting how quickly things are moving. So I just wanted to finish with one more quick demo. So please pray to the demo gods for me. We have a language model as well. this Mistral model. And so what we can see here is I wrote a Dagger pipeline that prompts the model, tell me a short story. Well, I'll tell you about the code in it once I've started running it, because it takes a second to run. It is Mistral LoRa.python. So there's something we have to do here, which is going to get fixed soon. So you have to tail the logs of a separate container to see it working. So yeah, that model is spinning up. I've asked it to tell me a short story about a plucky CI/CD startup in San Francisco that overcame great obstacles and ended up conquering the whole world of AI by mistake. I just thought that would be funny. It's doing it. It's telling us the story. The founders were two young programmers, Samantha and Alex, who had a passion for building fast and efficient systems. At QuickBuild, they focused on using cutting edge, blah, blah, blah. I'll just let you read. It's probably more fun than if I read the story out. But yeah, this is Mistral-7B, and it's now, like I said, also possible to fine-tune Mistral-7B. So just like we did with the image model, it makes it possible to, yeah, there you go, and it's finished. Just like you could see with the image model, where we could give it specific data to a specific business, you're now going to be able to fine-tune these language models really rapidly on small data sets and get good performance out of them. So yeah, that's good. I kind of showed you the code already. So I'll just spend a couple of minutes talking about the roadmap, and then there's time for questions. So the first thing I'm looking forward to on the roadmap, on the Dagger roadmap, and then the rest is kind of like my roadmap for other things I'm planning to work on, is I'm really looking forward to GPU support landing. I know folks have been working really hard on that, and it looks like it's now working, and we're just waiting for it to be merged. So that's really exciting. That's nice because at the moment in the code, we have some fairly terrible hacks in order to get GPU support working from inside Dagger, whereby we have to spawn this Docker socket forwarder that binds to the Docker bridge IP address, and then run another container from inside the Dagger container that has GPU support, and bind mount the Docker socket. It'll be really nice to be able to dramatically simplify this code, and it will also mean that you are now able to get the standard out from the container directly in Dagger, which is something that that we had to work around in this example. So that's going to be good. I'm also really excited about Zenith. I think it'll be really interesting to see the ecosystem of modules that get created by that. And what I'd like to do is package all of the complexity that I've hidden behind the demos I showed today inside a Zenith module. So you'll be able to just say, like, with AI, and then pick a language model, generate this answer, or generate these images. And so you'll be able to use Dagger for driving these kind of heavily cached AI workflows to generate the fine-tuned models and then also run inference on them. So I'd like to plug in more models as well. So there's, as well as the ones I've showed you today, which are language models, which are like text to text, and image models, which are like text to image or prompt to image. There's now language models that can take images as input. You've probably seen ChatGPT 4V for vision. There's an open source version of that called Lava, which looks very good as well. And there's a version of Lava that's been built on top of Mistral, which looks even better. And then there's also text to video models coming out, like there's one called Hotshot XL. Yeah, I'm excited about all of those things. I also have a vision for, once we package all of these AI things inside a Zenith module, being able to drive those from a backend service that can manage fine-tuning in a friendly web interface on behalf of a user. And so I'm working on this, but it's not finished yet. But I thought I'd just give a sneak peek today. So we have a web interface here called Dagger GPT, which will allow you to create a new chat session. It's a bit inspired by the ChatGPT interface. And then you'll be able to select between text and images to either create SDXL images or have a conversation with Mistral here. But there's also a mode where you can fine-tune it with text or even fine-tune it with images. So you'd be able to drag and drop like your own images from here, and then directly through the web interface, kick off those fine-tuning runs that we saw kind of on the back end. Yeah, I'd love to see this ecosystem of AI modules exist to be able to drive user-friendly use cases like that. I'd love to hear everyone's thoughts on everything I've shared today. So yeah, that's the end of my talk. Thank you very much.